Hello everyone, Elias5891 here with another KTANE module tutorial. This time we're going to go over the Neutralization module. Relatively new one. It's had a few changes in the manual since it first came out, so we're going to look at the newest version and see how we're going to solve this. Now this does require edge work, so we're going to start with that as usual. One battery and one holder. Lit NSA. Two parallel ports, serial port, PS2 port, and RJ port. Serial number 2, uniform 3, Mike Romeo 1. There we go. So this is neutralization. There's three things you choose here. You choose a chemical, a base. You choose a number of drops of base, and you decide whether or not to have a filter. And when you're done, you hit the titrate option, and that's your submit button. Now, figuring out what we need to set these to, not that bad. As the diffuser, you'll need to tell the expert the color and volume in this white bar here. So this one would be yellow 10, that would be yellow 20 up in the corner, red 5 down here. But we're going to do this one, yellow 10, yellow 10. And they're going to go through, as the expert, you're going to go through each of these, do the calculations, there's a lot of them sometimes, to figure out the three items that a diffuser will need, and that's going to be your base, your drop count, and your solubility, whether or not you filter. And you're going to go through these in order. There's no back and forth messing around. You're just going to do them top to bottom. We're going to start with determining titrants. The acid type is determined based on the chart. I mean, it's just what color is it. In this case, it's yellow, so we're using hydrogen fluoride. It's HF. Now, I'm going to actually hop down here to the bottom page. Here's HF, hydrofluoric acid. You'll notice it has a little section here for the anion, the chemical symbol, and the atomic number. I'm going to take special note of those because they're going to be relevant in my calculations. That gets me my acid type. Step 2, find my base. This is edge work primarily, as well as what we've already calculated. Base determined using the following rule set. If the bomb has an NSA indicator and exactly 3 batteries. Not the case. We had 1 battery and no NSA. Actually, we do have an NSA, but 1 battery, so that's false. Otherwise, if the indicator has a lit car, FRQ, or IND, it does not. Otherwise, if the bomb has no ports, it has quite a few. Otherwise, if the acid's chemical formula, that's this HF, which I got from right here, if the acid's chemical formula has a letter in common with an indicator present on the bomb. So if any letters in this case H and F, are present in any indicators I might have, then we apply this. But I don't have an H, I don't have an F. Next rule. If the number of D batteries is greater than the number of AA batteries. I've explained this in a couple others, but once you have the battery and the holder count, if you subtract batteries minus holder, that gives you the number of pairs of AA, and the leftover batteries are D cell. So in this case, we have no AA's because 1 minus 1, and we have 1 D battery. So we do have more D batteries, so we're going to add ammonia. Ammonia here is NH3, and we're going to jot down the cation on this one, just like we did for the anion down there. That's hydrogen with atomic number 1. This is your base. That is going to be the first piece of information you're going to convey back to the diffuser when you're done. But not yet. Let's finish up. Next, we have to determine the concentrations of the acid in the base. To do the concentration of the acid, we start with the atomic number of the acid ion. That's this first number I grabbed from the chart down below. The number here. In this case, that's 9. We subtract the atomic number of the cation of the base. That's the 1 we grabbed from here. Puts me at 8. If the anion or cation has a vowel in the chemical symbol, so in these symbols, not the whole thing, just the symbols of the cation and anion, If there's a vowel, we're going to subtract 4. We don't have a vowel. We have H and F. If the anion and cation's chemical symbols have the same number of characters, triple, multiply by 3. Yeah, they're both one character, so we are going to multiply by 3. We're going to triple that. Comes 24. We take the least significant digit, removing negatives, so that's going to become 4. If the number is 0, we don't have to worry about that rule right now. Otherwise, divide by 10, that gives you your concentration. So we divide by 10, and it gives us 0.4. Next, we find the concentration of the base, and this is a pretty basic set of rules. You're going to tell if you have more battery holders, port types, or indicators. If you have a tie, or if you've got this special case here. Let's look at the special case first. If the combination is HI and KOH, it is not, or HCl and NH3. We have NH3, the ammonia, but we don't have the HCl, the hydrochloric acid. So this rule is not going to apply. So we had one holder, one indicator, 4 port types. So we have more port types than battery holders or indicators. So the concentration for the base is 10. Next, we determine drop count. We're going to start with 20. We're going to divide by the concentration of the base. That's the 10 we found out earlier. Gives us 2. We're going to multiply by the volume of the acid. That was 10. We're going to multiply that by the concentration of the acid. We got 0.4. Just do 2 times 4 is 8. So 20 times 0.4 is 80, but you got to put a decimal place in one spot. So 8.0 drops. So this is our drop count. Last step, we determine our solubility. We simply look at our cross section for our acid and our base, HF, NH3, and we see if it's soluble. This is NS, it is not soluble. If it's not soluble, then we have to filter it. So in this case, we're going to have the filter on. If it was soluble, if it gave us an S, then we would turn it off. There you go. So we've got the 3 things we need to tell our diffuser, so we're going to tell them, okay, your acid is your base is NH3, drop count is 8, filter on. Makes a very satisfying sizzling sound when it's done. That's a quick run through of it. Let's do one more. We'll pull up another bomb so that the base rules can change up. Let's pull up one more. Here we go. We're going to work on this one here. Let's actually zoom out. It is a blue 20. And let's get our edge work. We have no batteries at all. We have 2 parallel ports and a serial port. We have 2 indicators, lit MSA, lit NSA, and our serial number is, Echo Whiskey 7, Quebec Whiskey 5. Interesting to note on this one, I have another blue 20 to match the one on the front. They will have the same answer. Nothing about the module is going to change it part way through. It doesn't change as it goes. So if I got the answer to this one, it would be the exact same answer on the other side. We know it's blue 20, so let's start. Step 1, find acid. Blue solution is hydrogen iodide, HI. Hydrogen iodic acid, hydroiodic acid, sorry. So that's HI. The anion is I with an atomic number of 53. For the base, if the bomb has an NSA indicator, yes, and exactly 3 batteries, no. Otherwise, the bomb has a lit car frequency indicator, nope. Otherwise, if the bomb has no ports, nope. Otherwise, if the acid's chemical formula, HI, has a letter in common with an indicator of the bomb, no H's, no I's, so nope. Otherwise, the number of D batteries is greater than the number of A batteries. Nope, they're equal at 0. Otherwise, if the anon's atomic number is less than 20, it's 53, so it's not. Otherwise, add lithium hydroxide. So lithium hydroxide, LiOH. That's going to give me Li for my chemical symbol for the cation and an atomic number of 3. Let's go ahead and mark this so we remember to give it to the diffuser. We start doing concentration. Start with the atomic number of the acid, subtract the atomic number of the base. Not the actual acid, the base, the cation, the anion. So 53 minus 3 gives me 50. If either has a vowel in the chemical symbol, yeah, they both got an I, so we subtract 4. 46. If they have the same number of characters, I versus Li, they do not. Take the least significant digit. That's a 6. Your least significant digit, remember, is always the one on the right. The one with the least place value. If the number's 0, nope. Otherwise, divide by 10. So our acid concentration is 0.6. For the base concentration, let's make sure we don't have one of these combos. HIKOH, nope. HClNH3, nope. So of battery holders, port types, and indicators, we have a tie. We have two port types, and two indicators. So if there are any tires for the most, the concentration is either 5, 10, or 20, whichever is closest to the cation's atomic number. The cation, remember that's the second one we got from the base. Its atomic number is 3, that's closest to 5. So my base concentration is going to be 5. Now we get our drop count. Start with 20, divide by base concentration, gives you 4. Multiply by, let's go ahead and multiply by volume first, is 80. And multiply by the acid concentration, 0.6. 8 sixes is 48. Last, do we need the filter? We have HI, LiOH. This is soluble. This is an S. So we do not need the filter. Our base is LiOH, lithium hydroxide. And our drop count is 48. Let's go ahead and just do it here on the back for fun. Now, if you do get this wrong, it does make a very satisfying sound. The sound of a shattering beaker. It always makes me happy to hear that. But that's concentration. After you've done it a few times, you'll probably start to learn, A, the names for the acids and the bases, which you'll notice I used kind of interchangeably. You'll learn which chemical is the cation or the anion. Eventually, you may even learn their atomic number. I had to study that in school, so I know those semi-well, but certainly not something that you would be expected to know for this. But that's it for this one. This is concentration. So thank you for watching. As always, if you have any comments, questions, concerns, or suggestions, leave them in the comment section down below. Let's see if I can detonate. Nope, nothing works. Until next time, thanks for watching, have fun, and don't explode. Bye, guys.